Hi, today we're going to be looking in more detail at the PISim simulation models. We already looked at the user interface and how to load configurations in the previous video, so let's just load the stir tank heater. This is our stir tank heater simulation. All of our simulation models are represented by P&I-like diagrams, and each diagram has a number of hotspots for the input and output connections from the process. Outputs from a simulation or from a real process always come from measuring instruments. Control is really information processing, and the process outputs from a control viewpoint are always streams of information. If we move the cursor over one of the transmitters, you can see that it changes to a connection pointer. These transmitters are the process outputs. The process inputs from a control system viewpoint are always some sort of final control element. And in the process industries, these are usually the control valves. So there's hot spots on these control valves. You can't see them at the moment because we don't actually have a device that's capable of connecting to them. We would need to add that separately. Actually, let's just do that just now. We'll configure this as a controller. Let's make it a TC and take the output out the bottom. Oops. Okay, so we've just configured a controller there, really just to get an output port so that I can show that it connects to the input port of the valve. So we have output and an output stream of information flowing from this controller out and into that valve. Okay, let's just get rid of that. Simulations in PISim are treated just like the other components that make up the P&I diagram. They have inputs and outputs, and it's also possible to configure them. To get to the configuration menu for a simulation, you simply move the editing cursor into some free space, right click and then select configure. Although PISim simulations have a fixed structure, it isn't possible to edit the simulation equations. We've made a large number of the simulation parameters user adjustable. Being able to adjust these parameters means that you can produce quite different dynamic systems from the same simulation model. As you can see, the stir tank heater has a large number of user adjustable parameters. We've also included the ability to enter the parameters in a variety of units by selecting from the drop-down lists. Internally, PISim converts everything to SI units, but if the user wants to use alternative units, the processor conversion is completely automatic. Having such a wide range of parameter choices can be quite confusing, so all of our PISim simulations can perform check calculations if the user requests. These calculations might work out steady state values or estimate time constants. In the case of the stir tank heater, we can press this check button and you can see that it calculates the heat transfer area based on the jacket size and the liquid level in the tank, the exit temperature based on a whole bunch of things, and the approximate time constant for temperature changes in the tank. And that's just with these parameters, so we could change one of the parameters. Let's change this to 15 and do a check, and you can see that the time constant has changed. That's dropped because we're increasing the flow through the tank, and also the exit temperature has changed. That's dropped as well because we're putting more liquid into the tank too. And that's really all there is to configuring a PISim simulation. I hope you found this useful. Goodbye.